Lesson 10.5, Pythagorean Theorem. In a right triangle, the hypotenuse is the side opposite to the right angle. So, opposite the right angle. That would be the hypotenuse. This is always the longest side. The other two sides that make up the right angle are called the legs of a right triangle. Pythagorean theorem says this, that the sum of the squares of the two legs is equal to the square of the hypotenuse. In other words, a squared plus b squared is equal to c squared. In this lesson, we will use Pythagorean theorem to find missing side lengths of right triangles. We're also going to be able to identify whether or not a triangle is a right triangle. Just for a moment, let's recall that a right triangle is a triangle that has one right angle, that is, an angle that measures 90 degrees. A converse statement is when the hypothesis and conclusion of an if-then statement can be exchanged and the statement is still true. That is a converse statement. So we will be looking at the fact that if a triangle is a right triangle, then the square of the length of the hypotenuse is equal to the sum of the squares of the length of the legs. And conversely, if the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse, then you can state that it is a right triangle. The ifs and the thens can be interchanged. Okay, let's practice finding the missing length on a right triangle. Number 1, the first thing you need to note is which sides are your legs and which side is the hypotenuse. So, notice that 10 and 24 are the legs. We'll call those A and B. And our missing side length is the hypotenuse C. So the way that we will work these problems out is the first thing you're going to do is write the theorem, the Pythagorean theorem, which says a squared plus b squared equals c squared. Then you will substitute the values from the triangle into the Pythagorean theorem. So if a is 10, then a squared is 10 squared. B is 24, so b squared is 24 squared, and c is our variable that we want to find, equals c squared. Okay, the next thing you need to do is simplify. So 10 squared is 100, plus 24 squared, which is 576, equals c squared. Now, 100 plus 576 is 676 equals c squared. Then you will go ahead and find the square root of both sides. And so the square root of 676 happens to be an even 26. Because we're talking about the measure of the side of a triangle, we're only going to consider the positive root of 676. Okay, so in this case we didn't have to round to the nearest hundredth, but in the case that we have a decimal, we'll always round to the nearest hundredth. Okay, number 2. Here we have a right triangle, and we can identify that the hypotenuse is 15, so we'll label that as C. B is one unknown, and the other leg A would be 7. Okay, so step number 1, write down the Pythagorean theorem. A squared plus B squared equals C squared. And we will substitute A, B, and C. So A is 7. 7 squared plus B is our unknown, equals C squared, which is 15 squared. Let's simplify. 49 plus B squared equals 225. Now let's go ahead and subtract 49 from both sides. B squared equals 176. And now we have to find the radical of both sides. So B equals 13.27 when rounded to the nearest hundredth. Okay, let's go on to number 3. Please copy down the figure. Notice here your hypotenuse is in the form of a radical. That doesn't change the process at all. Okay, so let's identify our sides. 5 is a leg, and radical 77 is our hypotenuse. So first step again is write down the Pythagorean theorem. A squared plus B squared is equal to C squared. Let's plug in our values. That's 5 squared plus B squared is equal to radical 77 squared. So let's simplify. 25 plus B squared is equal to 77. When we subtract 25 from both sides, we can see that B squared is equal to 52. And then we can go ahead and find the square root of both sides. So that B equals 7.21 when rounded to the hundredths place. Okay, number 4, please do this one on your own. Pause the video, work it out, come back and check your answer. Please check your work for number 4. A is equal to 10.58 rounded to the hundredths place. A Pythagorean triple. A Pythagorean triple is a group of 3 counting numbers. Our counting numbers are 1, 2, 3, 4, 5, etc. So a Pythagorean triple is a group of 3 counting numbers that satisfy the equation a squared plus b squared equals c squared. So if you have 3 numbers that you can substitute into this equation, a squared plus b squared equals c squared, then those 3 numbers are considered a Pythagorean triple. It's important for you to know that c must always be the largest number, because c in a right triangle is always the longest of the 3 sides. Okay, so now we're going to determine whether each set of numbers is a Pythagorean triple, and can those sides can the sides be the sides of a right triangle. Here we go. Example number 5. The numbers are 9, 12, and 16. So what we need to do is we need to run those numbers through the Pythagorean theorem. A squared plus b squared equals c squared. And if it works, then yes, this set is a triple. If it doesn't work, then it's not a triple. So all we need to concern ourselves with is that the longest side, or the largest number, 16, is substituted for c. Okay, so let's plug in 9 squared plus 12 squared is supposed to equal 16 squared. Let's see if that's true. 9 squared is 81. 12 squared is 144. And 16 squared equals 256. So you need to ask yourself, is it true that 81 plus 144 is equal to 256? Well, the answer is no. That does not make any sense. So this is not a Pythagorean triple. Okay, number 6, let's try it. A squared plus b squared has to equal c squared. My only concern is that I picked the longest side to be c. So 30 squared plus 40 squared equals 50 squared. Let's substitute. 30 squared is 900, 40 squared is 1600, and 50 squared is 2500. Is it true that 900 plus 1600 is equal to 2500? The answer is yes. Therefore, those three numbers are a Pythagorean triple. Okay, try number 7 on your own, please. So number 7 is not a Pythagorean triple. When I substitute my values, notice that I did substitute the longest side for c. Okay, remember that in a Pythagorean theorem, the hypotenuse is always c and it's always the longest side length. Okay, when I simplify here, 144 plus 36 does not equal 18 squared, which is 324. Okay, let's do 8 together. Notice that number 8, you have some that are in radical form. That doesn't change the process, though. We can go ahead and substitute. The only thing we'd have to figure out is which of those three are the longest side. 2 radical 10, radical 41, or 3. Which is the longest side? Okay, so as I look at these three values, I recognize that radical 41 is just slightly longer than 2 radical 10. So I'll designate that to be C. All right, so here we go. We do a squared plus b squared is equal to c squared. So let's go ahead and substitute. 3 squared plus 2 radical 10 squared has to equal radical 41 squared. Okay? All right, so 3 squared would be 9. 2 radical 10 squared is 40. And radical 41 squared is 41. So the question is it true that 9 plus 40 equals 41? And the answer is no, therefore this is not a Pythagorean triple. Okay, for some independent practice, find the missing side lengths for number 2 and number 5. And then let's determine whether these are Pythagorean triples or not. You'll do number 5 and number 8. Okay, remember to write down any questions that you have. We'll go over Pythagorean theorem tomorrow. We'll practice a little bit more then. All right, God bless you. Have a great night.